Most automation promises relief from routine work, do the repetitive tasks faster, and humans are left with the important parts. But as AI systems take over predictable work, something less obvious happens. The exceptions become the main problem. At first, automation simplifies jobs. AI handles the common cases, the standard inputs, the things that follow clear patterns. What remains for humans looks manageable. Fewer tickets, fewer decisions, fewer interruptions. Over time, though, the nature of human work changes in a specific way. The routine disappears, and what's left is everything that doesn't quite fit. To understand this shift, it helps to look at how AI systems are designed. Many current AI systems work by learning patterns from past data. They perform best when situations resemble what they have seen before. Repetition is their strength. Edge cases, by definition, sit outside those patterns. They are rare, messy, or context dependent. They don't repeat cleanly, and they often involve conflicting signals. When AI handles the majority of cases, the proportion of edge cases in human work increases, even if their absolute number stays the same. This dynamic is already visible in customer support. Automated systems answer common questions, process standard requests, and route issues efficiently. Human agents step in when something goes wrong. What they handle now is different from before. Cases are more complex, emotionally charged, or ambiguous. There is less repetition and more judgment. The job doesn't disappear. It becomes cognitively heavier. A similar pattern appears in content moderation. AI systems filter large volumes of obvious violations. What reaches human reviewers are borderline cases, context-sensitive decisions, cultural nuance, or situations where rules conflict. The work shifts from volume to interpretation. Each decision takes more effort, even if the total number of decisions is lower. Efficiency increases, but cognitive load does not necessarily decrease. In software development, AI tools generate boilerplate code, suggest fixes, and automate testing. Developers spend less time writing standard components. What remains are integration issues, architectural decisions, and debugging problems that don't follow templates. The easier parts are reduced. The harder parts become more central. This effect is not limited to digital work. In healthcare administration, automated systems process routine claims and scheduling. Human staff deal with unusual cases, exceptions, and disputes. In logistics, AI optimizes standard routes. Humans intervene when weather, regulations, or unexpected events disrupt the plan. Across domains, automation pushes human effort toward the edges of the system. One credible counterargument is that as AI improves, it will absorb more of these edge cases too. That does happen. Over time, some exceptions become common enough to be modeled. The boundary shifts. But the boundary does not disappear. As systems expand, new edge cases emerge, often created by the system itself. Automation changes the environment. That creates new situations the model was not trained on. There is also a risk in how organizations interpret this shift. When AI handles most cases successfully, remaining human work can appear inefficient or slow. Management may underestimate the difficulty of exception handling. But edge cases are hard precisely because they resist standardization. They require context, negotiation, and responsibility. Treating them like routine tasks can increase stress and error. Another subtle cost is learning. When humans no longer handle routine cases, they lose exposure to the full distribution of situations. New workers encounter disproportionately hard problems without the gradual buildup of intuition that repetition provides. This can make onboarding more difficult and reduce confidence. Some organizations respond by reintroducing training simulations or rotating roles to preserve learning paths. Beyond individual roles, there is a coordination challenge. Edge cases often involve multiple systems interacting. Resolving them may require crossing organizational boundaries, interpreting policy, or improvising solutions. AI excels at optimizing within defined systems. Humans end up managing the gaps between systems. As automation increases, those gaps become more visible. This doesn't mean automation is a mistake. Removing routine work can reduce burnout, improve consistency, and free up time for higher-value tasks. Many people prefer fewer repetitive duties. The issue is expectation. Automation doesn't leave humans with less work. It leaves them with different work that is rarer, more complex, and often harder to measure. Organizations that adapt well recognize this shift. They redesign roles to reflect higher judgment demands. They provide support, escalation paths, and time for decision making. They don't assume that fewer tasks automatically mean easier jobs. The system works when the human role is acknowledged, not minimized. At the organizational level, this pattern reshapes how productivity is understood. Efficiency metrics often count volume. Edge case work resists that logic. Its value lies in preventing failure, resolving conflict, or maintaining trust. Those contributions are real, even if they're harder to quantify. As AI continues to absorb routine tasks, exceptions will matter more, not less. Human work will concentrate where systems break, overlap, or fall short. In many current automation systems, this is not a temporary phase, but a recurring structural outcome. Understanding this helps set better expectations for organizations, for workers, and for the design of AI systems themselves. Because when machines handle the average case, the remaining work is defined by everything that refuses to be average.